Hello everyone. Today we will see about how to do process replacement. Earlier in the previous sessions we have seen how to duplicate a process. The duplicated process was called the child process, and the duplicated process was so called duplicated process because the new process that was being created, that was the child process, was duplicated process because it was executing the same code. So you have had two different processes executing the same code, isn't it? But here, today we are going to do something new. Replacing the process image means the new process will come and replace the old process. One system call loads the binary program into memory using the loader from the secondary storage into memory, and it starts executing. And when the process comes into memory for execution, it needs a process context. So every time the loader loads the program into memory, a new process context is created. But what happens in process replacement is that suppose there are two different processes, then the two different processes will sit in the secondary storage. You have to execute both the processes one by one. You start with the first process, and the first process is loaded into memory for execution. And the first process then invokes the second process. So you will have your process which is already compiled, and the compiled program is suppose kept in the secondary storage. Okay, this is a compiled program kept in the secondary storage. And let's say there are two different programs which are compiled and kept in secondary storage. Executable linkable format files in secondary storage, ready for execution. Okay. Now what happens is you load one program in memory, and when the program comes in memory, it expands in memory and starts to execute. This is the process context. Process context, which starts to execute. It will have its own stack segment, code segment, data segment. It will have its own file descriptors and the process table and the thread group table, various things. It will also have a task structure. Of its own. It will have a task structure of its own. Okay. Now, it is your first one process that got executed, loaded by the loader into memory for execution, and it is working now. One system call loads the binary program into memory, replacing the previous contents of the address space, and begins new execution of the new program. Now, when this program executes, then this program in its code segment executes the code and gives a system call called execl. In the code segment, it gives a special call called code from the code segment. It will give some system calls. I will elaborate the code segment here. Suppose in the code segment it gives a special call execl with some arguments. Now this system called execl, which was given from inside this code segment, here you will have the name of the other program to execute. The other program will come and get executed. Now when the other program will come in, it will need the process context, and it will need the task structure also. The current process have the process context, and the current process have the task structure also. Okay. Inside the task structure, the current process have listed things like PID, PPID, and various other things. Okay. So using EXECL, you can invoke a new program from the existing program. But when the new program comes in, the new program needs a process context. This is how it happens. The original program executes. It has some statements. Statement 1, 2, 3, 4, 5, 6, all the statements to execute. Okay, it has so many statements. All these statements will execute. Among these statements, there is a special statement called EXEC program. When this EXEC will execute, it will take another program name as an argument. That another program is also an executable program. When the EXE system call is made, it will start invoking the other program from the current path or file name, whatever is given. Okay. The EXEC itself has a routine associated with it that will execute. When it will execute, it will find this program in the file system and check that it is executable and it is ELF format. If yes, then the new program will be loaded for execution, and the new program will come in for execution and will need a process context. It will not create a new process context. Instead, it will load in the same process context that the original program was executing. It will overwrite the process context of the previous process, and the previous process will be killed, and the new program will overwrite the stack segment, code segment, data segment, all the file descriptor tables and everything, and hijack and occupy the process context of the previous process and start executing in the process context of the previous process. Also, it will hijack the task structure, the PCB of the previous process. Hijack the task structure also, and the new program will start executing in the same process context of that of the previous program. You get that? The new program loads in the same process context of that of the previous program. These functionalities provided by EXECL family of calls. You can use the man page for EXEC. It's a family of calls, 6 calls in total that you see here: EXECL, EXECLP, EXECLE, EXECV, EXECVP, and EXECVPE. You have these 6 calls here working. Okay. The new program starts execution with a given argument appearing in the BRA pass domain that we'll discuss in a moment. These are the family of calls. We'll see these one by one. Okay. Starting with the first one, EXECL. EXECL takes some arguments that we'll discuss now. Okay. EXECL is a system call that executes the new program. Okay. And L stands for list of arguments. When it executes a new program, it also has a list of arguments that are supposed to be supplied to it. Okay. EXECL. Hold on. Now, you see it takes arguments. One is the path / file name. The very first argument to EXECL is the path or file name. Let me take it into the Jamboard for you. So the very first argument to EXECL is path or file name of the new program that you want to invoke from within the current program. So let me arrange it for your understanding. EXCCL. The very first thing about EXCCL, it is used to replace the current process image, and the new process will come in, and load in the same process context of the previously executing program. The new incoming process, there are two processes involved. One is that the process that is giving the EXCCL system call, and another is a process that is going to be incoming process that is going to be loaded by the current process. Now this is the path of the new program that is going to get loaded. Path and the file name of the new program that is going to get loaded is this, as is given here also. The EXCCL system call does what? The EXCCL system call replace the current process with the new incoming process. The new incoming process will come and override the process context of the previous process. The previous process context is overwritten by the new incoming process. You must understand this by now. Now the task structure of the previous process is also hijacked by the new process. Therefore, the new process will execute with the PID, PPID and many other attributes of the previous process. Means the new program will take up the PID of the previous process. The new program will also take up the PPID of the previous process and will execute the PID and PPID of the previous process. Now the very first argument. The loader is able to identify the file to load using this path. See, we have given the path of the new program that is going to come in. We have also given the file name of the new program that is going to come in. Okay. So using the path and the file name, the loader is able to understand that which program needs to be loaded, and that program will get loaded. Okay. The new program will get loaded and will start executing in the process context of the previous program. It says the file to load is checked for ELF format. It must be a ELF format program. The loader uses struct mm to identify where to load the new incoming program in the process context. Let me show you this. How does the loader understand that the new incoming program should be loaded in the same in which process context? There is a header file called sketch.h in which you have task structure. Here it is. Struct task structure. Inside task structure, there are two fields. struct and active. The loader looks at these two fields and using it finds that what is the process context starting ID where the new process should come in and get loaded. Okay, so the loader uses struct to identify where to load the new incoming program in which process context should it get loaded. Okay, so this is understood using the structure map. After that, it has arguments. Now this first argument is the new incoming program must be able to accept command line argument. The new incoming program that will come in, that will get loaded into the process context, should be able to get the command line arguments. Okay, so that is main there should be main that should be taking arguments int argc char star argb. The new incoming program should be able to accept command line arguments using main function int argc char star argb. Now the new incoming program will take arguments from where? The main function in the new incoming program will accept arguments argc char star argb, where arguments.
Here's something I found on the web. According to dogplayer.net.
Stop. The main function will have int argc char star argv. Okay. Now this char star argv is listed here for the new incoming program. It will take some arguments, and the arguments will be supplied by the outgoing program. Outgoing program is the program that gave the execl call. Okay. When it will identify the path and the file name of the program to execute, after that it will give the list of arguments. All the arguments will be strings. All the arguments will be supplied from the program to the incoming program, and the incoming program will accept all those arguments in argv 0, 1, 2, 3, 4, n. How many arguments are supplied by the current process is not known. How many arguments will be accepted by the incoming program is not known. Therefore, the last argument is always set up as null. Okay, which tells that no more arguments are there to be loaded. I hope you understand this. You can ask your doubts if you have any. So execl, okay, where L stands for list of arguments that are going to be supplied from the outgoing program to the incoming program. Okay. Now this is what happens. You have a current process which is executing, and in the current process you have the PID, PPID, program counter. Say program counter is going to go from 1111 to 2222 through the code segment. Okay, I have elaborated the code segment here, and these are 0, 1 and 2 file descriptors. When the program will start executing, say the program counter proceeds further and reaches 1155, at bit going from 1111 to 2222, the program counter have reached here 1155, and at this point it gives a open system call, and it opens a file. So the file is opened, and you will have the file descriptor number 3, file descriptor of the new process. Okay, then say your program counter proceeds further and reaches 1199. At 1199, from here it goes ahead and it gives a fork system call. When it gives the fork system call, a new child process is created, which will have its new task structure, new PID, new PPID, which is the PID of this program. The program counter of the child process will be copy of the program counter of the parent process 1199. This we have seen earlier, isn't it? We know that the child process shares the file descriptor with the parent process. So both the parent and the child process will refer to the same set of file descriptors. The child process do the exec. That we will see in a moment. Hold on. Let us first start implementing execl. Suppose I create a simple program. Watch this program in which I give the file name using underscore underscore file underscore underscore. I give the PID, I give the PPID using get PID and get PPID, and I print start and I print end. Simple program, isn't it? And we execute this program. it reprints the PID, PPID, isn't it? Simple program. Now the EXECL program. I am going to print the file name PID, PPID start of a program. After that I do EXECL. Watch carefully. EXECL, the first argument is supposed to be path and file name. So your first argument is dot is the path, that is the current directory, slash file name. You saw that? Path slash file name. The second argument is argv0, which is going to, second argument is argument number 0, which is going to go into argv0 of the new incoming program. And you know very well that the argv0 is always the current file name. So therefore I have given the current file name as the first argument, and then I'm not supplying anything else. No more arguments in here. Okay, and the program will print end. So this program, at this path, I showed you just now, I executed. This was the output. So now I'm going to execute the second program, which is this. I have already compiled. Done. Watch the program output carefully. The file is 02.execl, which is the second program, whose PID is 53300 start. So this statement is printed. After that, I do execl and the new program starts. And the new program's file name is 01id.c. See, it executes with the same PID of the previous program. The previous program have given the execl call to the new program. The new program came in and overwrite the previous program, hijack its PCB, and starts executing with the same PID, same PPID of that of the previous program. New program start, and then the new program end. But what is this? The end statement of the previous program did not print of the 02execl.c. The end statement did not print because the previous program was overwritten by the new incoming program. So the previous program was killed. It was not there. You get that? So this is how the process replacement happens. Any questions? Yes, Amardeep.
सर नाउ इन दिस एग्जांपल आपने हमें दिखाया कि कैसे जो हमारा अभी करंट प्रोसेस है और प्रोसेस टास्क स्ट्रक्चर है वो ओवर रिटर्न हुआ है. सर नाउ मैं एक क्वेश्चन है कि
नहीं, टास्क स्ट्रक्चर ओवरराइट नहीं हुआ है.
हाँ, प्रोसेस कॉन्टेक्स्ट है.
प्रोसेस कॉन्टेक्स्ट ओवरराइट हुआ है.
नाउ सर, अगर हम सिस्टम कॉल यूज करके अगर किसी भी प्रोसेस किसी अलग फाइल को चलाते हैं तो सर उस केस में क्या होता है?
When you use system call system to invoke a new process, then the new process runs in a separate process context.
Oh, okay.
And the control jumps to the new process context. When the new process context is over, control returns back to the previous process, and then previous process continues its execution further.
Okay, sir.
Okay. Let's have a look at another example. Here, I print file PID PPID start. Then I start another program. I do execl. This time I have used P. Execl P. Now execl here. execl L stands for list of arguments. Okay. The L in the execl. stands for list of arguments. If you use execl p, the execl p also works like execl only, with slight difference. The p has its own significance. In this code, p means refer to path environment variable. Refer to path environment variable. Now, if you notice carefully, then we have not given the dot here. Earlier we have given dot. Earlier we gave dot slash. You see in this program, previous program which I showed, I had given dot slash. That means I specified the path myself. But in this program where I am using p, I am not specifying the path myself. The path of the new ELF file is not specified by user. Instead, the path of the new file will be taken from path environment variable. Okay, the id dot of 01.id, a new file, should be stored somewhere on some path given by path environment variable. Okay, we won't give the path here. That means we should compile this file, and after compiling it successfully, we should copy this file to some path which is specified in path environment variable. Then it will work. We will see it now. Here is the file 01.id. I have not specified the path. Now the path environment variable, will be used to find this file. This is the first 0th argument and no more arguments. Okay, so let us see if we are able to execute this. Program number 3A. I have already compiled it and I run it. Oh, it runs. That means in some previous sessions I had copied this 01.id program into path environment variable. So therefore we are able to execute it from some path in path environment variable. Okay, execl p. So mark it clearly, the difference between execl and execl p. execl, in execl, L stands for path environment variable. In execl p, see, L is still there, means there are going to be list of arguments. There is p also, now that is added to it. That is, the path will be taken from path environment variable. I hope it is clear. Let's have a look at another example.
सर मेरे क्वेश्चन था, सो जनरली हमें कोई भी हम कोई प्रोग्राम इंस्टॉल करते हैं तो हमें पाथ एनवायरनमेंट वेरिएबल में उसका पाथ जो है रजिस्टर करना पड़ता है, तो इस केस में ऑलरेडी रजिस्टर्ड था इसलिए, या
हाँ, वो मैंने I had copied this program to path environment variable in some previous class for
Okay.
some other batch.
Okay, sir.
Okay. Now look at this program. I print the start statement. Okay. Then from this current program, I am starting another program using execl. The new program is in the current directory and called 03.test. Let's open the new program also. Here is the new program. Okay, 03.test. Now the new program is going to take command line arguments. Now the first program, give the path /file, because we are not using p, we are using only execl. So therefore the path environment variable will not be used. We have to specify the path ourselves. /file name. Then this is the argument 0, which is the file name. Then I pass more arguments: alpha, beta, theta, gamma, and null. All these arguments should be passed from the current program to the new incoming program, and the new incoming program will capture all the arguments through the current argv array. So the new program will print start. It will say argc, how many arguments you have to captured, and all the arguments are 0, 1, 2, 3, alpha, beta, theta, gamma will be captured and printed here by the new program. And then the new program will finally print the end statement. You will never be able to return control back to the previous program, and the previous program's end statement will never execute, because the previous program would have been overwritten by the new incoming program, and would have the code segment, data segment, stack segment, and everything for the new program, even the list of file descriptors, everything was replaced. Okay, so the previous program was kind of murdered. Let's see how it runs and how we pass arguments. Watch that. So I've already compiled it. Let me run it now. Here you see, we start this program, file name with this PID start. Then after that it gives execl call to this program, and this program so many arguments are captured. And then the new program starts, the test program. Start, total number of arguments are 5, and I print only the first 4 arguments: argv0 file name, argv1 alpha, argv2 beta, argv3 theta, and there was one more argv4 gamma, isn't it? We have not printed it. So this is how the previous program will load the new program, and this is how the arguments will be passed from the previous outgoing program to the new incoming program. Okay. Let us have a look at another example. Yeah. The new program will again print the start statement just like before, and then the new program will invoke another program, path /file name, alpha, beta, gamma, null passed as arguments. And the new program name is 04.test. There it runs. The new program will capture the command line arguments. Start argc1, 2, 3. It is printing the file name. It is printing all the command line arguments that is passed from here. Nothing new in this. Now, this is another program. This program will print the start statement, then it will open the file. It have a file descriptor. It will print file opened successfully. It will print the file descriptor number also. I think it should be 3. Then it is going to do execl and start a new program 05.test. Let us start the new program 05.test. This is the new program. All the command line arguments passed. This is the path and the file name. This is the command line argument number 0, which will go into argv0. This is the command line argument number 1, which will go into argv1, and this is null, which will go into argv2. So it will capture total 3 arguments, argv0, 1, 2. Total number of arguments will be 3, and will print argv0, argv1. Argv2 is anyway null, so we are not printing it. Okay. So let's run it. We are passing 2 arguments and will never print. We are passing 1 argument and 2 argument. Let's run this program. Execute. Now what happens? My program opened buggy file with the ID 998 start. My program opens the file successfully. And what is this? My program end. That means we are able to reach this statement. That means execl failed. Now why did execl fail here? Why it did not work? Well, because look at the data type of the second argument. First argument is a string. Look at the data type of second argument file descriptor.
Integer.
It is an integer. Now we cannot pass integer as argument to execl. We have to have a string here. Therefore execl failed. Another program in which again I am passing the same execl. I opened the file descriptor just like before, but after printing file opened successfully and I printed the file descriptor, then after that in second line using sprintf, S stands for string printf, I converted this file descriptor, which was an integer, and I printed this integer into sfd string of size 4. So printf will print to the default output, but sprintf will print it to a string buffer. So I have printed this character integer fd into a string buffer where you have char, 4 chars making up an integer. Now this is the string version of file descriptor. So I pass the string version of file descriptor as argument to execl, and now we exec the program number 06.test. Which is same here, which will accept the file descriptor. Here the string version of file descriptor, which will be accepted in argv1, and then using ASCII to integer, it will convert the string to integer and store the file descriptor in fd, and then print the file descriptor. Okay, first convert it into string and pass it as string, then accept as string, and then convert as integer to use the file descriptor in the new incoming program. Let's see how it works. Here you see, it says the previous program starts, the previous program opened the file descriptor successfully, and the previous program exec a new program which takes 2 arguments. The 0th argument is file name, and the first argument is string version of file descriptor printed, and then the integer version of file descriptor printed, end. This is how execl works. You got that? Process replacement. Another example. Yeah. The new program starts, prints the start statement. The new program, the first program, opens the file descriptor, gets the file descriptor, and says that the file opened successfully and file descriptor number is printed. Then after that, the program writes some buffer in the opened file. The buffer says stay home, stay safe, keep training, grow big. Okay. We write it into the file. And then after that, the process will say wrote some bytes as returned by the write system call into the file. After that, it will do execl and start a new process. argv0, argv1, string version of file descriptor, prepared using sprintf. The string version of file descriptor is passed as argument to 07.test. So let's go to this file. It will get the file descriptor as argument. argv0 will be the current file name, argv1 will be the string version of file descriptor. Okay, it will say argc2, argv0 will be the current file name, argv1 will be the string version of file descriptor which will be printed. Then the string version of file descriptor will be converted to integer using a to I, and the integer version of file descriptor will also be printed. Now the new program has got a file descriptor. The file descriptor which is passed from the previous program. The previous program had written some data into the file and taken the file position to the end of file, and then the file descriptor is passed as argument. So the new process has got the file descriptor which is at the end of file. So we do else seek and bring this file descriptor back to the beginning of file, and then read from the file, and you'll be able to read data into the buffer, and you'll say read how many bytes, and you'll print the buffer using string in which you'll read the data that is passed from the other file into the new file. Okay, so let's see how it works. I hope you are able to understand what we are doing. So we have involved the file in between two processes. One process is writing into the file and goes away. A new process comes into the process context of the previous process and reads data from the same file. So let's see how it works. There you see, first process says wrote 23 bytes into the file, and second process says read 23 bytes, and here it is. Did not print anything, everything. This is not 23 bytes, this is more than that. This is 48 bytes. Why did it write only 23 bytes?
सर बफर का साइज डिफाइन कितना होगा?
No, that's not needed. You're not getting the string length correctly. let's print it. That's okay. Wrote 48 bytes successfully, and then read 48 bytes, and there everything you have, right? So it's working fine. So we are able to write data from one process to another process. This is the first of a kind inter-process communication that we have done. But we have involved a file which is in the secondary storage. So it's going to be very slow. This kind of implementation is called mailbox. Okay, so guys, this was my first-hand introduction to you to process replacement.
सर क्या बोलते हैं उसको प्रोसेस को?
Process replacement or setup where one process writes and another reads from a temporary buffer, and the temporary buffer is implemented in some file in the secondary storage. This setup is called mailbox.
Mailbox, right?
Yeah. Okay. So guys, that's all I have for you today. And in process replacement, it is not over yet. Remember, there are 6 different calls. So we'll need one more session to cover up for the other 5 calls, and then we have to you learn to use the fork and the EXECL both together. Okay, we'll need 2 different more sessions actually for this. Okay, so that's all I got for you today, and I'll catch you people tomorrow in the next session. We'll discuss EXECL further. Thank you.